Right, hi everyone. This is my next video in the series on calculus, and this is now going to go through some other differentiation rules. In the last video, we looked at how we differentiate polynomials. That's basically functions which start with y equals something x to the power of something. But there are different rules for different types of functions. And so with this video, we're going to look at some of the other rules. So first of all, let's just remind ourselves of the polynomial rule. That was you had to multiply the number in front of each term by the power of x to become the new number in front, and we also had to reduce the power of x by 1. So the rule was if y equals ax to the n, then dy by dx equals an x to the n minus 1. So let's just look at a couple of examples. So here's a simple one, y equals 5x cubed minus 3x squared plus 7x minus 9. So first of all, it's y and x, so we need to become dy by dx. Then multiply the 5 by 3, it becomes 15, and reduce the power by 1, so it's 15x squared. Take the next term, 2 times minus 3 is minus 6, so it's going to be minus 6x to the power of 1. Or minus 6x. The 7x just becomes 7, and then minus 9, numbers just disappear. Here's another example. V equals 7t to the minus 1 plus 0.5t to the minus 2. So this time it's not y and x, it's v and t, so it should be dv by dt equals. And then we multiply the power by the number in front, so we get minus 7t to the minus 2. And in the second term, it's minus 2 times 0.5, which is minus 1. So it's minus t to the minus 3. Last example, this is quite a hard one, but 7/8 x to the 2/3 is going to become 14 over 24, which is 7/12, x to the power of minus 1/3. If we take 1 away from 2/3, we get minus 1/3. So it's 7 over 12, x to the minus 1/3. And then we multiply the next term, we multiply the minus 1/2 times minus 7 over 2. That becomes plus 7 over 4. And then it's x to the minus, instead of being minus 1/2, it's going to become minus 1.5 or minus 3 over 2. So it's 7 over 4 x to the minus 3 over 2. Okay, so now we're going to look at some other rules. First of all, we're going to look at sine and cosine. Now the rule for this is written at the top of the screen here. It says sine becomes cos and cos becomes minus sine. And we need to multiply the number in front by the number from inside the sine or cos. So let's look and see what that means. So here's do the sine rule first of all. The sine rule, sine becomes cos. So you can see here we have sine and we have cos. But we also need to multiply the number in front, in which case is a b, and we need to multiply from the number inside the bracket, so the number inside the sine or cos. So it becomes that a here is multiplied by the b, so we need to multiply those two together. And that gives us ab. The ax bit, the bit that's being signed, doesn't actually change. That still stays the same. So let's just look at an example. So you've got y equals 12 sine 3x. If we differentiate that, first of all, it's dy by dx equals. Then we need to change the sine to a cos, so it becomes cos 3x instead of sine 3x. But we also need to multiply the 3 by the 12 to get 36. Here's another example with the cos. So this time it's y equals b cos ax. It's going to be changed, the cos is going to become minus sine, and we need to multiply the a by b. So if it was y equals 7 cos 6x, dy by dx would equal sine minus sine 6x, but we also need to change the number in front, so it becomes minus 42 sine 6x. Now there's a few notes, a few things you need to remember. First of all, that I know this is probably obvious anyway, but you should never have sine of nothing or cos of nothing on its own. That doesn't make any sense. It's like square root. It doesn't make any sense. You need to be square root of something. The second thing is sine becomes cos, but when you differentiate, cos does not become sine. Cos becomes minus sine, and that's a very important thing to remember. The bit that's being signed or cosigned doesn't change, so that bracket bit stays the same. And you need to remember that you only multiply the number from within the bracket times the number in front. You don't multiply the x. You shouldn't be moving x's anywhere in this differentiating. And the last thing is, sometimes there is a minus sign inside the bracket and a minus sign outside the bracket, so you end up multiplying two minuses, and two minuses make a plus. So here's the rule again, and then we'll look at some examples. So here's the first example: y equals 5 sine 6x minus 2 cos 4x. Now I have no idea what that graph looks like. It's going to be some kind of wavy shape, but first of all we're going to find the gradient equation. So first of all, it's y and x, so it's going to be dy by dx. Then we look at the first term, and it's a 5 sine 6x. So the sine 6x is going to become cos 6x. But we also need to multiply the 6 from inside that bracket with the 5 to become 30 cos 6x. If we look at the next term, it's a cos term. Now cos terms, when you differentiate them, become minus sine. Now it already is a minus, so minus times a minus is going to become a plus. So it's going to become plus something sine 4x. But we also need to multiply the 2 by the 4 to get 8. So it's a plus 8 sine 4x. Okay, let's do another example. It's a little bit harder. We've got some decimals in here. 2.5 cos x minus 5.2 sine 0.5x. Again, is y and x, so it's dy by dx equals. Cos becomes minus sine, so this is going to be a minus term. The whole thing's going to be a minus term. And we need to multiply the 1 from inside the bracket with the 2.5. And that becomes 2.5 still. So it's minus 2.5 sine x. If you look at the second term, sine becomes cos, so that's going to become cos 0.5x. But we also need to multiply the 0.5 times the minus 5.2, which is minus 2.6. So it's minus 2.6 cos 0.5x. Okay, last example. This one has got fractions in it, just to make it a little bit harder. It's y and x, so dy by dx equals. Sine 4x over 3 is going to become cos 4x over 3. But we also need to multiply 4/3 times 1/6, which is 4/18 or 2/9. So it's 2/9 cos 4x over 3. The second term is a cos term, and the cos is going to become minus sine. So we're going to have minus something sine 2x over 9. And you've got to multiply the 7 over 4 by the 2 over 9, which gives us 14 over 36, which is 7 over 18. So it's going to be minus 7 over 18 sine 2x over 9. Okay, that is the sine and cosine rules. There's one more thing you need to know, which is the exponential rule. So the rule for exponential functions. Now, exponential functions are basically functions that have an e in them, and we did e earlier on in the year. E is just a number, like pi. It's called the natural number, and its actual number is 2.718, and it goes on and on. It's used a lot with things that grow and decay, or charge and discharge in engineering. So, what's the rule? The rule is we multiply the number in front by the number in the power to become the new number in front, but everything else stays the same. So in actual fact, exponential functions are quite an easy one to do. So if the rule is there, y equals a e to the bx, then all you've got to do is change the number in front. The e to the bx bit stays exactly the same and just becomes ab at the front instead of just a. So here's an example. If y is 5e to the 2x, then we need to multiply the number in the power, which is the 2, and we take that number and we multiply it by the number in front. So 2 times 5 is 10. but the rest of it, e to the 2x, just stays as e to the 2x. So we get an answer of 10e to the 2x. A few things you need to remember about exponential functions. First thing is that it is easy because the only thing that changes is the number in front. The second thing is please don't move any x's. It's only numbers that get multiplied. Just like in sine and cosine, where you multiply the number inside the bracket, this time it's just the number in the power. Okay, so let's do some examples again. So here's the rule. Multiply the number in front by the number in the power to become the new number in front. Everything else stays the same. So here's the first one. Y equals 5e to the 3x. So it's y and x, so it's going to be dy by dx equals. Now, the e to the 3x is going to stay exactly the same, so there's no change there. The only thing that's going to change is the number in front. Instead of being 5, we've got to multiply the 5 by 3 to get 15. So it's going to be 15 e to the 3x. Here's another example, slightly harder example, but not much. It's y and x again, so it's definitely dy by dx. The e to the minus 0.12x is going to stay exactly the same. The only thing that's going to change is the number in front. So we need to multiply 100 by minus 0.12. When you do that, it becomes minus 12. So the whole answer is minus 12 e to the minus 0.12x. Okay, one more example, this time with fractions. So it's y and x, so it's going to be dy by dx. The e to the x over 4 is not going to change. The only thing that's going to change is the number in front. So we need to multiply the 4/5 by the number in the power. Now, this time, the number in the power, it could be confusing, and I think this is the tricky thing. It's not 4. It would be 4x if it was 4. It's x over 4. So if you took the x away, you'd be left with 1/4. So really, we're multiplying 1/4 times 4/5, and that just gives us 1/5. Hope you can see that. The number in that power is a quarter, it's not 4. So a quarter times 4/5 is 1/5 e to the x over 4. Okay, those are all the rules. So we can see them all listed there. The first rule is the polynomial rule. The second two are the sine and cosine or trig function rule. And the last rule is the exponential rule. Okay, that's all the rules you need to know about differentiation. And just before we finish, I just want to remember what we're doing. When you differentiate something, you're finding the derivative or the gradient equation. And once you've got that equation, you can then find actual gradients. So finding the derivative is only part of the job. You've got to use it to then find a gradient. So here's an example. Y equals 3 cos 4x when x equals pi over 3. It might look a little bit odd, but it's a fairly simple question. So first of all, we have to differentiate it. We don't want to put pi over 3 into that original equation. Otherwise, we'll just find the y value when x is pi over 3. We want the gradient. We want dy by dx. So we have to first of all differentiate it. Now, I don't know whether you remember, we've just gone through how to differentiate cos. Cos becomes minus sine, and we need to multiply the number in the bracket with the number in front. So we get minus 12 sine 4x. There's the derivative. Now we need to put x equals pi over 3 into that, and that will give us the gradient when x equals pi over 3. So we substitute x equals pi over 3 into this equation, and you get that. One thing I haven't mentioned, and it's quite an important point, is whenever you're using sine and cos, you have to have your calculator in radians, not degrees. So you'll have to change the setup of your calculator. This is why we did radians earlier in the year, so you know what they are. Pi over 3 is actually exactly the same as 60 degrees. But we've got to put pi over 3 into these equations, and we've got to make sure that your calculator is in radians. If we do that, we get the answer of 10.39. So that is the gradient of y equals 3 cos 4x when x equals pi over 3. Okay, and that's it. That's basically all we need to know about differentiation and all the rules.